Okay, so let's look at part 2 of the review. The first thing I want to talk about before we even do a problem is this with calculator. Like, yes, you get a calculator on part 2, but I would add that it is rarely needed. Oh, did I freeze it? Oh, my face is frozen. It sure is. Unfreeze my face, maybe. So you'll always have it. You can certainly use it to check things. It might make factoring easier. It might make, if you have to do 6 times 8 and you've forgotten what that is, like you'll have the calculator. But it's really only needed on one problem. So we're going to do most of this worksheet, or at least the ones we do together, without the calculator, except I'm going to have it close by in case I get stuck or want to check something. But again, it's rarely needed. If you look at these questions, and it's like most of these will factor. So I don't really need a calculator to work these. So let's do number 3. Again, you've got a calculator, so you could plug it in and look for the zeros, but I think there's an easier way to do this one. Any thoughts on factoring that guy, Joanne?
So, I was thinking, could do grouping?
Yes, let's group. Because you can almost tell by looking that they look like parallel, like something's going on here.
Also, it says try to rank algebraically, so that just means that even if we wanted to get our answer straight away, we can't really.
Well, it means you can use your calculator to get your answers, but I do want to see work. So if you need your calculator to kind of prompt you along, okay, but I do need to see the work. Let's see, x squared, x minus 3, plus 2 times x minus 3 equals 0. Hey, what do you know? This is nice when we group and the leftovers are the same. X minus 3 times x squared plus 2 equals 0. So let's back up, make sure we do the directions correct, because we can ask all sorts of things with these. Solve. So I'm just looking for answers. So x equals 3, there's one answer. And some of you are to the point where when you see x squared plus 2, you'll jump straight to the answer. Others of you, probably most of us, should probably set that equal to 0 and show a few steps. And then realize, oh yeah, square root of a negative, that's I. Don't forget the plus or minus. So plus or minus I root 2. Okay, question time related to that. How many, Karis, how many total roots, how many total zeros does that thing have? 3 total zeros. Benji, how many real roots does it have? 1. And then one more question that I bet Jenna knows. How many x-intercepts would that have? 3. Well, 1, because only the real zeros are x-intercepts. So the real zeros, those show up as x-intercepts. So this would be one where you're like, okay, I've done with the problem. Maybe I finished the test and I want to go check it. And I have a bunch of different ones in my calculator so I don't have to erase them and start over. But I don't have this one in there. Whoops. Let's see. X cubed minus 3x squared plus 2x minus 6. And I don't know if you know this or not, but when you highlight the equal sign, you can turn on or off whether it shows up on the graph. Because I definitely do not want to see all 4 of those on the graph at once. Okay, so here's number 3. I'm expecting 1 x-intercept. I got it at x equals 3. There's some wiggling going on elsewhere. That's the imaginary root stuff down there, but it's not an x-intercept. So this looks like an x cubed. The table could confirm that x equals 3 is a 0. And the graph confirms that I've only got 1 x-intercept. And so that would be a good use of the calculator. It didn't take too long to check and sort of verify all my algebra work right there. Maybe you save it to the end. Maybe it's one where you like star it and come back to it later rather than checking all of them as you go.
I have 2 questions. So you can't use the calculator to check any imaginary roots, right?
Okay, if you're really good and you want to check, your calculator knows how to do I math. Second I is down there at the very bottom of the decimal point. Second I root 2. So if I want to plug that in and see if that works, like it should, then I don't really want to type that in the whole time. I'm going to store that. This is way more than you want to know. Store that as A, and then I can do, I'm really going to be fancy here. Oh, except that one wasn't Y1, that was Y4. You asked, so you're getting an answer. Y4 at A should be 0. Oh, it doesn't like it because it's imaginary. Yeah, I'm really having to work here. What? That didn't work? That should have worked. I don't know why that one didn't work. Okay, maybe you can't. I thought you'd be able to plug in an imaginary number. I root 2. And it didn't like it. Okay. So maybe you can't.
Also, my other question was, there is one somewhere else in the packet, I don't remember where, but it said show your work algebraically, and it looked like you're supposed to factor, but when you try and factor by grouping, it you can't really factor it, the things don't match up.
Okay, we'll do one of those later. Like if you need to, and even on this one, if you use your calculator to find x equals 3, showing your work could mean that you, let's say you didn't know how to factor, and from your calculator you got x equals 3 as an answer. You could synthetic divide and then use this. There's your other factor.
Oh, so showing your work could just be any work?
So that would count as showing your work. That would be showing your work after you use the calculator.
So showing your work can just mean just showing that what you found is equal to 0, basically?
Yes. Because we know you have a calculator, you're allowed to use the calculator. So yes, that would count. It's just I feel like this is longer than this. If you know how to factor, then factor. We'll do some later where you kind of have to do that. All right, that was a lot on number 3, but that's okay. We covered a lot of stuff. Why don't you try number 5? Before we get started on number 5, though, Dylan, how many real zeros does number 5 have? 4. Ava, how many real, wait, what did I ask Dylan? Did I ask you total zeros?
Real zeros.
Okay, real zeros, I don't think we know the answer to that yet. Total zeros is 4. Real zeros, Ava, I just gave away your answer. Real zeros is x-intercept. We don't know until we either graph it or factor it. So there should be 4 answers. I don't know what kind of answers they are yet. All right, so try number 5. So factor with cubes. X equals negative b plus or minus the square root. Here's where the calculator might come in handy. If you need to square 4 minus 4ac all over 2a. So, again, required, no, but you've got it, so don't mess up 16 minus 64. 4 plus or minus square root negative 48 all over 2. Yes, sir?
Will the calculator do PEMDAS, or will it go left to right? Does it know how to?
It knows how to do, yes, so if you're thinking 16 minus 4 times 16, yes, it'll do PEMDAS. It'll do 4 times 16. So
you put all of that?
you could put all of that. I mean, it's good that you're asking the question, and you should have a mental check on like what you think your answer should be. But yes, your calculator will do PEMDAS, which is why. Side note here, which is why when you do -4 squared like that, what's the calculator tell me that's going to be? The calculator knows PEMDAS. Exponents come first, so that's -16. So be careful. If you want to square -4, then fine, but make sure you're squaring -4. Okay, 4 plus or minus, let's see, 48. Again, I got a calculator, so why not? Pretty sure 48 is divisible by 16. So 4I root 3 over 2. Then I can divide 2 into both of those pieces, so 2 plus or minus 2I root 3. Okay, how many answers do I have? 4. How many real answers do I have? 2. How many x-intercepts will I have if I graph this thing? 2. So, again, I'm done with the problem, but if I'm curious... Oh, that one's not in there either. If I'm curious, or I want to check things, maybe I wasn't sure about the quadratic formula, did I mess that up? Oops, 128. Struggling today. 2x to the 4th plus 128x. Graph. Oh, that's kind of misleading because I see the -4. I think the x equals 0 happened. It just happened so steep and so straight down the line that I almost couldn't see it, or I can't see it. But there's 2 zeros there, and there's 2 imaginary zeros somewhere, which means if I zoomed way out, I could probably see it. Probably more than you want to be doing on test day. There it is. I made my Ymin and Ymax 100 to see it. But that's going to mess me up later, so I don't want to do that. Again, you've got the calculator, use it wisely. Like you can use it a lot, or you can use it a little, or you can use it not at all. And it's probably the case that the less you need it, the better off you are. But hey, it's there if you do need it. Brian? No. Like if you get down to x squared, you're going to use quadratic formula, or at the worst, you'll use quadratic formula. What I thought you were going to ask is one like number 10, like solve that, but I can't factor that thing. So how am I going to use a calculator to help me factor that? What could I do? How can the calculator help me factor? That one I do have in there. What will I be looking for on the graph? The zeros. Or maybe even the table, even better. But remember, table only tells you integers, so who knows if that's helpful or not. Jeremy? Okay, so you can actually do grouping on this one, like 3 groups of 2, and it works out. I don't think most people see that, so I'm going to use the calculator way. But yes, this one actually could group with groups of like 3 pairs, I guess, and it works out. But I don't think most people see that, so I'm going to use the calculator. Oh, all 5 of them are real roots. I'm checking the table, oh, look at that. What am I looking for on the table? A 0 where? On the y, and I got one at -5. So I don't have to do the second calc 0 business. I found one that will work. So I'm going to use -5, and then I will synthetic divide what should I get for a remainder if negative 5 is really a 0? What should my remainder be? 0. So this should work, but the point of this isn't to show that negative 5 works. The point is to get an easier polynomial to deal with. And this turns out to be a much easier polynomial to deal with because all of those zeros. So yes, I got 0 at the end, but the main point was now I've got 5x to the 4th minus 14x squared plus 8. Reading direction here. Factor completely and find all the zeros. So let's factor that. 5x squared and x squared. My only option for 5. 8, I've got choices. 1 and 8, 2 and 4. Let's see, everything would have to be negative. If I put the 2 across from the 5, that would make 10. 4 by itself, yep, I can get negative 14 out of that. It did say factor completely. Those are not factorable. I can't factor either of those any farther, but there is one more factor that I need to include. What other factor do I need? Oh, be careful, x equals negative 5 is one of my answers, which means x plus 5 is one of my factors. So there's my factors. I've already got negative 5. For these, let's see, 5x squared equals 4. So x squared equals 4/5. Plus or minus. Trying to see how much I can skip at once here. That would be 2 over square root 5. But we don't like that as an answer, so 2 root 5 over 5. And then the last one is much easier. X squared equals 2. So plus or minus square root 2. So factored completely, also found all the zeros.
Wait, so can't you just, if you take the negative 5 and then you do the synthetic division,
Uh-huh.
can't you just, wait, you would just factor the simplified, that polynomial, right?
Correct.
Like normal. And then you get all your factors?
Yes, because yes, I get all my factors.
Oh, okay.
So let's see. Back at the beginning, we knew there'd be 5 zeros. Do I have 5 zeros here? Yeah, because that counts as 2, that counts as 2, so 2, 4, 5. How many of those are real zeros? All of them. They're all real zeros, and that matches with the graph. So again, calculator shows me 5 real zeros. I suppose if I really wanted to check one of those, I could find one of those. And the student asked me yesterday to make sure I recorded how to find a 0 on the calculator. So second calc 0. Where in the world? Oh, there's my cursor. So I guess we'll find that one. Left bound, right bound, guess. So one of my answers is 0.894. I need to be careful. I don't want to box that as one of my additional answers. I'm just trying to see if that matches one of the answers I already have. It's not the square root of 2, because the square root of 2 is 1 point something. So I wonder if that's 2 square root of 5 divided by 5. 0.894. So yeah, that's the same as that one. So again, that's sort of overuse of the calculator, but I think you'll have plenty of time. So if you really wanted to go all out and like check all of the answers, left bound, right bound, guess 1.414. Since I've already done this a few times today, I know that that's the square root of 2. So now I feel like I've checked both of those. guess I could really go check the others as well, but that's enough of this problem. Jeremy.
Could you just find all the zeros by doing left-bound, right-bound, and then go backwards?
So, could you go backwards, like find all the zeros this way first and then work backwards?
Yeah, sure.
So, yes, in theory, but that means how are you supposed to know, like, okay, again, I've taught math forever, so I know that 1.414 is the square root of 2. But if I get 0.894, I definitely do not recognize that as 2 root 5 over 5. So going backwards is nice for easy answers, but it's basically impossible for crazy answers, unless you just got lucky and recognized one. Now, you do need to be careful because there is kind of a middle ground in there, because someone earlier today got this as an answer, and they're like, oh no, that's not a good answer. And I'm like, oh no, it is a good answer, right? Because what's 0.333333333? 1/3. I should be careful, this is not part of this problem. So that would mean 3x minus 1 is one of your factors, x equals 1/3. So Jeremy, the answer to your question is, can you go backwards? It's like, it depends on what the roots are. If they're all nice, then yes. If there are some ugly ones in there, then you'll have to use the nice one and then work forward to get the ugly ones. Again, unless you're boy genius and know that that's 2 root 5 over 5, which should be impressive. Okay, let's see. What else do we need to look at? One more I wanted to see. Let's turn to number 20. In fact, I know I said odds, but let's mark out 19 and do 20. Because I think it's better prepped for the test. How's that for a hint? We can kind of work this one together. Ava, how many total zeros does that one have? 3. How did you know that? Good. So it's degree 3. It's going to have 3 zeros. I don't yet know how many real zeros it has. How do I figure out, or how do I learn how many real zeros it has? Graph it. So let's graph it and find the x-intercepts. See how many different equations can I put in my calculator. At least 6, apparently. So this one is definitely a calculator one, because I am not factoring that. That does not factor by grouping. Okay, there's my picture. So how many real roots does it have based on that picture? 3. It's got 3 real zeros. I don't know if any of them are nice zeros, but there are 3 real zeros. So let's find them. Although I guess I like using the table first, because it's sure easy if there is one. If not, so back to the graph. And second, calc 0. And I guess I'm going to have to do this 3 times. All right, so again, to Jeremy's question, like, there's one of my zeros. Is that some fancy square root of something over something? Probably, but who knows? The direction said round to 3 decimal places, so that's the kind of answer we're expecting on that one. Same thing with my second 0, negative 0.553. I don't recognize that as any special fraction. And then the last one, whoops. If you get the no sign change error like I just did, it's because I didn't get all the way to the right of the 0. The calculator is looking for the y value to change positive to negative. And if you don't give it that, it tells you there's an error. All right, so all 3 of these answers are weird answers that don't have obvious fraction equivalence. Giant?
Will there be like ones on the test that's really crazy that I have to like zoom out? Or like,
I don't think so. I think I remember everything being pretty normal.
like, be able to like see on the graph?
And again, there's only one that you really need the calculator for, and that's the one that's like this, because there's no way to get those answers without a calculator. X values of the extrema. Okay, so max, that's the top of a hill. Min's the bottom of a valley. So I've got one of each of those. And it asked me for the X values. So where in the calculator do I find max and min? Second calc, same place. Second calc, max. And then it walks you through, but it's the same steps as finding a 0. Get to the left of the 0, get to the right of the 0. 0.758 for my max. And then same process for the min. Left bound, right bound, guess. Negative 1.758. I don't know if that's unusual, if that's flukish, or both of those have 0.758. I don't know if that's what's going on there, but Karis? Yes. So if it was this graph, you would say there is no minimum. Side note, what about the absolute max? Yeah, and the absolute min? Negative infinity. Giant?
Wait, so extrema just means the local, like, maximum?
Yes. I don't like that this doesn't specify. We usually try to specify local versus absolute. So I don't like that this doesn't specify which one.
For local absolute, if there's like many different terms, would you have more than one?
You would have more than one, yeah. And that's actually why I marked out 19, because 19 looks something like that. So you have multiple mins, but only one max. Local. Absolute, you have an absolute min, but you don't have an absolute max. So that was a little more confusing than I wanted to worry about. Jacob?
On the graph, what should we expect us to sketch it, or should we like plot points and make it
Yes is the answer. The question was, do we sketch it or plot points? And the answer is yes, both of those. It's a sketch, it doesn't have to be perfect, but it's so easy to get points. Like, why not get a few key points and then sketch it on top of the points? So it doesn't have to be perfect, but we can use the table to get 0, 5, negative, oh, careful, we got a scale thing going on here.
Good morning, website. It's time for the daily announcement. Please stand for the pledge.
So you'd plot a few points and then sketch in from there.